Kia ora, Year 12. I'm going to start videoing the 6 questions that we did in the surprise integration test yesterday. I'm going to start with questions 2D and 2C. So 2D is this one here, and then 2C is the one with the chunk of a sine curve. Okay, so back to 2D, what have we got to do? Well, we've got a differential equation, so we can see we've got x and y all mixed up here, and we've told 1 point on the curve, and we have to find the value of y when x equals 9. So we know that we're going to have to separate the variables here and then integrate. So we get 2y dy is equal to 3 root x dx, and then we integrate each side with respect to y and with respect to x. So the left-hand side is really easy. That gives us y squared. With this one, it's very easy to go wrong with fractional powers, or it is if you're me, if you leave them in third form. So I'm going to start by writing that out with a fractional power, and then I'm going to carefully anti-differentiate. So I'm going to get x to the power of 3 over 2, and I want to end up with the 3, but not the 3 over 2. So the slow way of doing that is to pop down what we want. We want to have a coefficient of 3, and then multiply out by the reciprocal of that power. I know quite a lot of you will do that in your head, but it's very easy, I think, with this one to make a mistake and end up with a half instead of with 2. So we should get here y squared equals 2x to the power of 3 over 2 plus c. And as I've said in class, it is well worth just looking at that and differentiating to make sure that we haven't mucked up this coefficient here. So now we can take our value, which is the point on the curve, which is 4, 5, and substitute that in to work out what the constant is. So y squared is 25, and we've got 2 times 4 to the power of 3 over 2 plus c. So that's 25 is equal to 2 times, right, well, the square root of 4 is 2, and we want to cube it, so it's 2 times 8 plus c. 25 minus 16 gives us 9. So c equals 9, giving us y squared is equal to 2x to the 3 over 2 plus 9. And we're asked to figure out what y is when x equals 9. So y squared is equal to 2 times 9 to the power of 3 over 2 plus 9. So y squared is equal to 2 times 3 cubed, which is 27, plus 9, giving us y squared is equal to 63. So y could be either 63, the square root of 63, or the negative square root of 63. Now, the answer schedule for that year has just got the positive root. I'm assuming that's because they didn't take marks off if you left out the negative. But I can't see any reason here why y has to be limited to a positive number. If we go all the way back to the start, x obviously needs to be a positive number because we're taking a square root and we're not dealing with complex numbers. But y doesn't have any restriction on it. Okay, so I get 2 answers for that one. That's the first one. Now the second merit question in question 2 of that year was this one here. And this is one where I think slowing down a tiny bit to think about the best way to do this will help you. So the graph below shows this function, and the function is simply y is sine of half x. And it's got the lines x equals k and then x equals pi. We have to figure out the value of k so that the areas a and b are equal. So this is going to be one limit of integration, the k, but it's going to be much easier if I can first of all work with the pi and the 0. So the way I'm going to do this, and the way that the schedule did it as well, is I'm going to find the area of the whole thing. That's going to be straightforward. And then I'm going to figure out what k I need to get half of that number. So the area of the whole thing is going to be this integral. And that integrates to give me this. Whoops. Let's get rid of that. Negative cos of x on 2, and I've got to fix up a coefficient in here, so we go back and do that. So it's from pi to 0. So I don't want to have 1/2, so I have the reciprocal of it. So it's negative 2 cos of x on 2. between pi and 0. So that's the whole thing. Substituting in the limits gives me -2 cosine of pi on 2 minus -2 cosine of 0, which equals, just quickly sketching my sine curve, 0 plus 2. So the area of the whole thing is 2. What we want now is we need to solve this. So we want half the area here. So we could go all the way back to the start to do that. We know that it's going to be 1 is equal to -2. Sorry for the noise downstairs. I think that's Mario Kart. I'm not sure. So now we're solving for this limit k. So 1 is equal to -2 cos of k on 2 minus -2 cos of 0. That gives me 1 is equal to -2 cos of k over 2 plus 2. -1, I'm going very slowly here, -1 is equal to -2 cos of k on 2, giving us 1/2 is equal to cosine of k on 2. And if you just go back and look at what we're looking for a value of k that is between 0 and pi. Just cleaning that up, right? So we don't need to worry about the fact that there's a whole lot of, there's a general solution for that cosine equation. We know that we're sitting between 0 and pi, okay? So special triangles, here we are, 1, √3, and 2. We want this angle here, and this is pi on 3. So k over 2 is equal to pi on 3, giving me a final answer of k is equal to 2 pi on 3. Okay, that's all for this video. I'll try and get through the other 4 questions this afternoon. Thanks for watching.